Hello, my name is Lim LEE from KGSEA Math Circle, and today I'll be lecturing 3 problems from the AMC8 of 2025, namely number 4, number 15, and number 23. This is problem number 4. Lucius is counting backwards by sevens, and his first three numbers are 100, 93, and 86. What is his 10th number? So first, if we, by coding terms, do a brute force solution, we understand that the answer must be B because Lucius's first 10 numbers are on the list as follows. There's a better solution though, and that's knowing that Lucius is counting backwards by an arithmetic sequence with a common difference of -7. So to reach the second number, Lucius needs to subtract 7 from 100 once. To reach the third number, Lucius needs to subtract it twice. And to reach the 10th number, you just have to subtract it 9 times. So we can just subtract 9 times 7 plus from 100, which would give us 37. This is problem number 15, and I'll give you a few moments to read the problem. I think that was enough time to get a grip on the problem. So let's move directly to the solution. The answer must be C because there are 13 squares and 36 minus 13, which is 23 gold squares. When the grid is folded in half, there are 18 pairs of squares that we need to notice, each of which can be silver on silver pairs, silver on gold pairs, or gold on gold pairs. To find the greatest possible number of gold on gold pairs, we need to understand that the greatest multiple of 2 that is less than 23, number of gold squares, would be 11, because 11 times 2 is less than 23. Therefore, the greatest possible number of gold on gold pairs would be 11, as shown in the diagram below. For the least possible number of pairs, we understand that there are only 13 unit squares of silver, and to get the least possible number of gold on gold pairs, there needs to be a maximum number of gold on silver pairs. So if we have 13 gold on silver pairs, then we'd only have 5 gold on gold pairs. So the answer would be small m plus big M, which is equal to 16. This is the last problem. I'll give you a few minutes to read it. To approach this problem, the answer is B. And by property 1, we understand that x plus 1, where x is the 4-digit number that have all 3 of the following properties, x plus 1 is a multiple of 100. And by property 2, x plus 1 is a perfect square, so x plus 1 is equal to n squared for some integer n. If we list out all possible values of x, that would be 4 digits. X can be from 40 squared minus 1 all the way up to 100 squared minus 1, because 30 squared minus 1 is 3 digits, and 101 squared minus 1, 110 squared minus 1 is 5 digits. So when we do, because 40 squared minus 1 and all of these values of x is a sum to product value, we can understand that x's could be, for example, 40 squared minus 1, which is equal to 39 times 41. 50 squared minus 1, which is equal to 51 times 41, and so on. And by condition 3, the number needs to be a product of exactly 2 prime numbers. And we can see that when x is equal to 60 squared minus 1, that would be the only case where x works, because when x is 40 squared minus 1, for example, x is divisible by 3. When x is 50 squared minus 1, x is divisible by 7, and so on. Therefore, the answer would be B, which is 1. Thank you for listening to my lecture, and make sure to watch more.